Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our custom functions, function O1 and function O2. This video is part of a larger series in the numerical demo example. So this assumes that you have watched the earlier videos, particularly on setting up this project, as well as the main. What we would like to do in this video is focus solely on how we can create a function that can then be passed to our numerical methods examples, and particularly our function O1 and function O2, which we are simply defining as these. The first example, it's going to be y is equal to negative x squared plus 2x plus 1. And in the second example, we're going to use the exponent function as well as the sine function just to create an interesting function that then we can use in our numerical integration examples. Also note that this function name, function O1, is probably not the most useful, but the idea is that you can name this anything you want to and then ultimately pass it to your numerical examples. So your left rectangle by function, for instance. Also note that these functions accept a double input argument and return a double output argument. So the idea here is that you can, just like any other y equals to f of x function, you can pass it a value for x and you would essentially get y in return. So let's go ahead and get started on this. So you see that I have stubbed in my function O1 and also my function O2 in an earlier video. And what I'd like to do is I would simply like to go ahead and calculate our y utilizing our x. And so this is actually pretty straightforward. So all we do here is our results is essentially going to be our y. And at this point, then we just simply need to carefully convert our minus x squared minus 2x plus 1 into C code. And to do that, we can simply use an abundance of parentheses here. For the power function, you can either use the power function or you can simply multiply x times x. In this case, I'm going to just simply use the power function. And then we have our minus 2 times x. Probably also want to get into the habit of using doubles here, although it is not completely necessary. And then also plus 1.0. Likewise, for function O2, what we want to do is we simply want to convert this particular function from its MATLAB equivalent into our C equivalent. So to do that, we once again simply say results equal to, and it's going to be 1 plus, and for our exponent function, we simply want to use the exp function, which accepts a double. And once again, I encourage the use of parentheses here. So it's going to be the negative of 0.5 times our x value. And then we want to add that then to our sine of, once again, abundance of parentheses, 10 times x. And if you'll notice now, I'm not just simply dividing the 10 times x, but I'm actually dividing the return value of my sine function by x. And at this point, you should have successfully converted those sample equations into C code. Let's go ahead and test it by building it. And as I've mentioned earlier in the video, this assumes that you have already converted the logic of the switches into C code. And particularly now, if you'll notice here, I'm going to focus in on my left rectangle method in a second. And you'll notice here that for the interactive switch, I am accepting both function O1 and function O2 as potential entries by the user. So in other words, if the user, when prompted for the function, can specify function underscore O1 or function underscore O2, which then should call our left rectangle utilizing those functions. And if you notice here, I actually have a typo. So I'd like to go ahead and take a second to fix this. So for my second function, then I want to be able to call function O2. So I would encourage you to take just a second to make sure that there are no additional typos. I see one where essentially what I've done is I've copied and pasted the same mistake over and over again. So we'll take a second to go ahead and fix these, as well as under my compare. All right, so let's go ahead and save that. Let's go ahead and build it, and then let's give it a shot. So what I'd like to do now is I'd like to run my numerical demo. And what I'd like to do is I'd like to use my /i/left rectangle and by function. But unlike the earlier example, instead of using my sine, cosine, or tangent that were built in or provided to us by our math.h, what I'd like to do instead is I would like to specify my function O1. I can once again provide a x-min, an x-max, and then a number of intervals. You'll notice that I have function O1 repeated multiple times. That simply stems from the fact that in our function O1, we have a printf statement. So I'm going to go up here, right click once again, navigate, and go to the declaration definition. And I would encourage you, at least when you're testing this, to use this, but I would suggest adding perhaps a little bit more information. So function O1 called with %f. And in this case, what we can do is specify actually what the value of x was that was used when we called our function O1. Likewise, we can do the same thing with the print statement in our function O2. So function O2 was called with x equals to %f. Now, ultimately, this is going to slow down the execution of your program because it takes time to write to the console. So ultimately, you may choose to comment these out. Though in early development, a little extra noise probably isn't a bad idea. So we're going to rerun this one more time. We're going to once again provide function O1. Enter in an x-min. Enter in an x-max. And then enter in an n. And you'll see that we have called now function O1 a total of 10 times using 11 data points. And you'll see there is the area associated with that particular example. We can, of course, repeat this with our function O2. And what I would do is I would encourage you to do the hand calculations to verify that this function is, in fact, being accurately used to calculate the area. Now, a little point to make with respect to our logic in main that we can refine later on is note that when you run this particular example, particularly in interactive mode, if you provide a function that is not specified yet, so in other words, a function O3, it still continues to go ahead and ask you for the additional questions. And then it provides you with the help. So something to consider in your main is to check to see first whether or not your function is actually a valid function. So in other words, a little bit of rearranging with respect to your triaging here. Once again, not a significant change that has to be made right now. Hopefully you have found this video useful, and at this point can see how you can create your own set of functions that then can be used to calculate anything using our numerical methods. Once again, thank you for watching.